Okay, so in this video, we are going to see what is vectorization and how to select a particular element from an array. Right now, before moving ahead with this topic of vectorization, let me ask you this: what if there is a list and I want to multiply or let's say perform some arithmetic operation to each and every element of that list? What should we do? Okay, so let's write some code for this. So let's suppose I have this list which has 1 to 10 numbers in it. Now what I want to do is I want to multiply all these elements by 2. That is 1 into 2, 2 into 2, 3 into 2, 4 into 2, and so on. All right. So I have to perform multiplication, but not on the list, but the element of the list. All right. So in a general case, some people come up with the solution that if we multiply x by 2, this will the problem will be solved. But this is something that we call as replication base. Right. This is something that we call as replication, which will replicate the same list, same elements of the list in the same sequence twice. Here, we are not multiplying the number 2 by each and every element of the list, but replicating the same values in the same sequence twice. Okay. Now, this is where vectorization operation of a numpy comes into the picture. And this is why numpy is very important when it comes to the manipulation in terms of mathematics or doing some advanced level calculations. Okay. So, if we import numpy as np, okay, if I create the same list, that is a np dot arrange 1 comma 11, this gives me the same numbers but in the form of array. Now, the one which is important or very nice thing with the NumPy is it supports vectorization. Vectorization means when you are performing this kind of operation that you are multiplying, you are trying to multiply a number by, let's say, by an array, it will not multiply, or you can say it will not replicate, but it will multiply the number by the elements of the array. That means the value, the output that you will get after executing this line is something like this. So what you have done here is you have multiplied 2 with 1, which is an element of the array, with 2. So 2 twos are 4, and 2 threes are is 6, 2 fours are 8, and so on. Right? So again, this is what we call as vectorization. That here, if you are performing any arithmetic operation with an array, it will be done with each and every element which comes in the array. Right? It will be implemented. That arithmetic operation will be implemented on each and every element of the array. That is called vectorization. Not only multiplication, you can also perform, let's say, addition. So if I add a number, let's say 100, so it will be added to each and every term in this particular array. So currently, if I show you how my array A looks like, so this is again remains the same. This operation is not at all permanent. Okay, operation is not at all permanent. So if I add A by 100, this 100 will be added to each and every element of the array. So the new array will be 101, 102, 103, 104, and so on. So this 100 will be added to each and every element that is present in the array. That is called as vectorization. Similarly, you can perform, let's say, something called subtraction. So if I subtract the current array, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I subtract by 2, this is what it gives me. So if you subtract minus 2 by 1, it will give you negative 1. It will, if you subtract 2 minus 2, it will give you 0. If you subtract minus 2 with 3, it will give you 1. right? So again, what you are doing is you are performing arithmetic not with array but the elements of the array, and the output will be the array itself. Okay, the output that you will get is the array, right? So that is how vectorization is done. Not only this, you can also perform division. So currently this is my array. If you perform a divided by 10, so this is the result. If you perform a divided by 2, this is the result. 1 divided by 2 is nothing but half, 0.5. 2 divided by 2 is nothing but 1. So this is called vectorization, where the arithmetic operation is done on each and every element in a particular collection or a array for this example. Okay. Now we can perform this, uh, using this concept of vectorization, you can also check whether the number is even or not. All right. So before that, let us see uh, whether is it possible to use some other operators like let's say comparison operator in vectorization operation. So now let's go ahead and do this vectorization with comparison operator. Okay. Now we'll be doing this vectorization with comparison operators. So again, this is my array A. Okay. And what I want to do is I want to check what are all the numbers which are greater than 4, that is 5, 6, 7, 8, 9, 10. Okay, I want to check what are all the numbers which are greater than 4. Now before executing this statement, let me remind you guys, if you are performing any operation or if you are executing any expression with a comparison operator, all right, you'll get always the boolean value. So if 3 is greater than 4, it will return true. Since 3 is not greater than 4, it is returning me false. Okay. So if I perform this action that gives me all those values which are greater than 4, that means 5, 6, 7, 8, 9, 10. These are the values of which I am talking about, right? And since this returns, a comparison operators always returns the boolean value, that is true or false. This will return true for all the values which are greater than 4, and it will return false for all the values which are less than 4. So if I just run this statement, since 1 is less than 4, it returned false. 2 is less than 4, it returned false. 3 is less than 4, it returned false. 4 is less than, sorry, not less than, but 4 is equals to 4, not less than 4, it returns false. Okay. But here, if you see, the statement gets, let's say, true because 5 is greater than 4. That's the reason this gives me true. 6 is greater than 4, the statement becomes true and it gives me true, right? So this is how vectorization with comparison operator is done. Okay. Now you can also check whether the number is even or not using these comparison operators. All right. You can also check whether the number is even or not using these comparison operators. So what we will be doing is I'll be checking whether this number are divisible by 2 or not, and then the remainder is equals to 0 0 or not. So what I am going to do is mod 2, right? That will give you the remainder, and then I'll check whether it is equals to 0 or not. Whether the remainder of this particular value, it gives me 0 or not. Okay, so this will give me this array of true or false. So 1 ka remainder, if you divide 1 by 2, the remainder is again 1, it will give you false. Then if you divide 2 by 2, the remainder is 0, it gives you true. If you divide 3 by 2, the remainder is 1, it gives you false. Okay. So this is how vectorization is done on NumPy. But guys, this is not I am concerned about. Alright. This is not I am concerned about. Here I have taken two examples. One, the number, I want to check whether the number is greater than 4 or not. And second, I want to check what are those numbers which are divisible by 2, or what are all those numbers which are even numbers. This is giving me the boolean value. What if I want the actual number for which the condition become true? Okay, for which the condition became true. So what I will do is, there is a concept called masking. Okay? There is a concept called masking. So this is my array, and for the very first question, that what are all those numbers, what are all those numbers which are greater than 4. So this was the condition. So a greater than 4. This was the condition, right? So it gave me this boolean value. Now what I'll do is, I'll basically save this value in some a variable called mask. A greater than 4. So I have assigned this array to a variable called mask. Okay. Now what I'm doing here is, I will mask this condition on my actual array. Okay. I will mask this condition A is greater than 4 on my actual array using indexing notation. So if I run this code, this will give me the actual value for which the condition became true. Okay, this will give me the actual value for which the condition became true. Here 5 is greater than 4 condition was true, that is why you have received true over here. And I don't want the boolean value, guys. I want the actual value, actual number for which the condition was true. Okay, similarly, for checking whether the number is even or not, so here what are all those, let's say, what are the even numbers in my array? Okay, so what was the instruction to check the even numbers? It is a mod 2 divide by, a mod 2 equal 0. That was the condition. What I will do is, I'll again create the mask of this condition, a mod 2 equal 0. Okay, and then I'll finally mask this condition on my actual array using indexing notation. So this will give me all those numbers whose remainder is 0 after dividing it by 2. That means it will give me all the even numbers which are there in the array A. Okay, so this is how masking is done, guys. So again, to summarize, if you are using this vectorization operation, all right, using this comparison operators, you'll be getting the boolean values. Okay, for example, if you are checking whether the number is greater than 4 or not, it will compare all the numbers which are there in the in the array. Okay, and it will give you the boolean value accordingly. If the number is greater than 4, it will give you trues. If the number is not greater than 4, it will give you the false. Okay, that is vectorization. But if I want to see the actual value for which the condition became true, that means for these values, there is something called masking that we need to implement. So we will be masking this condition on our actual array that will give me these values. So basically here in masking, we are not concerned with the boolean values, but the actual value for which the condition became true. The masking condition became true. Okay, that is what we are concerned over here, right? So always remember these two important point. Vectorization with comparison operator will give you the boolean values. Okay? Boolean value, that is either true if the condition is true, or either false if the condition is false. Okay, but if you are performing masking, okay, masking will give you the actual value for which the condition was true, okay, for which the condition was true. So that is the two important statement that you should remember. Right, now let us execute this same, let us extend this masking concept a little bit more, and let's see how selection in an array is done. Okay, how to select a particular element in an array. Okay, so let's suppose I have a array called names. So np dot array. Now I'll be having some names like Jay, then Raj, and Jay again, then Kumar, then Mrityunjay, then again Kumar, then Jay, Rohit, Suraj, okay, and Ravi. Right. So these are the names that I have. Okay. If you see, Jay has been repeated a few times and Kumar has been repeated few times. All right. So let's suppose, okay, let's start this topic of selection. Let's suppose I want to select all the names where the value is, where the value is J. All right. So basically, it says select all the elements where the value is J. So what I will do, I'll create a condition over here where name equal J. All right. So this will give me the boolean value, right? This will give me the value, boolean value. Now if you create the mask of this particular array, if you I mean save it in a variable, let's do it in a different cell. So mask equals names equal J, and then if you mask this condition on actual name array, this will give you all the values where the name is J. Now, guys, till now we have used this variable called mask, but in the actual situation, it is not at all necessary to first save this condition in a variable and then to apply it. Okay, it is not at all necessary to save this condition in a variable and then apply it using masking. We can do the same thing in one go in one particular instruction where name is equal J. For the explanation purpose, I was not using this. Okay, so that you should not get confused why I have used the same variable twice. So basically the simple explanation is this is the condition of your mask, and here we are performing masking. Right, so basically this selects and gives you all the value where the name is J. Okay, similarly we can also select all the names where the value is not J. Okay, that means give me all the record except J. Right, so this is where not equals to sign comes into the picture. So names not equals to J, This will give you every other name but Jay. As you can see, there is Raj, Kumar, Mrityunjay, Kumar, Rohit, then Suraj, then Ravi. There is no name or no value of Jay here, right? So this is how we select as per our requirement. This is called filtering. We have filter out all the values which we need, right? I don't want to see any, let's say, value with respect to the condition that I have specified. Okay, let's suppose there are, guys, if you pay attention here, there are two repetitive values, that is J, which has been repeated three times, and then there is Kumar, which has been repeating two times. So let's suppose I want to create a selection operation. I want to make a selection where I should get all the values except this J and except this Kumar word or Kumar value. Okay. So select all the names, okay, except Jay and Kumar. That means your resultant array should not include the name Jay and Kumar, and which is basically you'll have to create two different conditions. So one condition where the name is not equals to Jay, and the second condition or condition number two, let's say condition one, condition two, where the names not equals to Kumar. So these are the two conditions. Okay. Now, guys, here keep this thing in your mind. Sorry. Um, what happened? All right. Sorry. So the notation was completely opposite. So name. So keep this thing in your mind. Since we need to use a logical operator here, right? As per the requirement, we are going to select all the name except Jay and Kumar. Okay, so I have created the condition, but here when both of this condition is true, then only we need the output. That means we are going to use AND operator, right? We are going to use AND operator. Okay? But here in NumPy, okay, here in NumPy, if you want to use AND operator, okay, you have to use this symbolic and, that is ampersand sign. And if you want to use or operator, again you have to use the symbolic or, that is pipe operator, pipe character basically, right? So to make this condition work, condition 1 and condition 2 you'll have to specify in this manner. All right, so this will give you all those values where the name is not Jay and Kumar. Now what I will do is I'll simply mask this condition, that is condition 1 and condition 2, on my name array. So this will give me everything except Jay and Kumar. So Raj, Mrityunjay, Rohit, Suraj and Ravi, these are the names that we have. Right? We have selected everything except Jay and Kumar. Not only this, there is no need to specify again a different variable for masking. You can do it in a same instruction. So names, okay, names not equals to Jay and names not equals to Kumar. It's just that do not get confused, practice it, use variables in the beginning, but try to use one line instructions. This will give you the similar result. Whether you are using the variable or you are specifying all these conditions in one go, the result will be same. one thing that you have to make sure, that while specifying this condition, you have to use this round brackets. Okay, you have to use this round brackets, or else it might give you some error. All right, so this is what the notation was. Now I want, let's say, let's reverse this condition, guys. I want all the names. Let's say if I use select all those names where name is Jay and Raj. Sorry, not Raj, Kumar. Right. This will give me all the names where the name is Jay and Kumar. So in order to specify that, let's first make the condition. So name equal Jay. That is the first condition. Then second condition is name equal Kumar. That is the second condition. And what we want everything. So whether the name is Jay or whether the name is Kumar, give me everything. Right? So we are specifying an OR operation over here, and we'll mask this condition on our actual array. This will give me all those names where the value is equals to J and the value is equals to Kumar. So we have an array where everything is J or Kumar. All right. Now what we are going to do is we are going to, let's say, replace. All right. So we need to, there are two different operations that we want to perform. So select all the values. Okay, select all the values which which is not Mrityunjay. All right, select all those values which is not Mrityunjay and assign them as Shiv. Okay, assign the name as Shiv. Right, where the name is not Mrityunjay, assign the name as Shiv. That means accept Mrityunjay, change all the records, replace all the values by this word Shiv. Okay, so what I will do, there are some sequence of steps. So step 1, we need to first select all the records where name is not Mrityunjay. So we'll create the condition for that. So names not equals to Mrityunjay. That will give you all this Boolean operations. Now what we will be doing is we will be selecting all this. I will be masking this condition on the actual array. So names not equals to Mrityunjay. So this will give me all the record where the name is not a Mrityunjay. That means all the record where there is no Mrityunjay but other values rather than Mrityunjay. Now the step number 3. Okay, so this was the step 2. Okay? And now the step number 3 will assign these values as Shiva. Step 3. Names not equals to Mrityunjay. If the name is not equals to Mrityunjay, assign it Shiva. Okay? Assign Shiva. So if I run this now, and if you check your name list, all those name which is not Mrityunjay now has replaced with Shiva. Right? So Shiva, 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 Mrityunjay, Shiva, Shiva, Shiva. Right? So that is how we can manipulate our array. This is how we perform selection operation. This is how we perform vectorization or masking techniques. Now, if you want to check how many unique elements do you have, you can do that using this np.unique. names. So there are two names, that is Mrityunjay Shiva. Okay. To summarize this, what we have done is, this is my array A, right? We have performed vectorization. We have seen what exactly vectorization means. That means if you apply any arithmetic operator on an array, on a numpy array, that arithmetics will be performed with each and every element of that array. Since I am multiplying array A by 2, it will be multiplied by each and every element of that array A. So that will give me the result 2, 4, 6, 8, 10, 12, and so on. Secondly, if you are performing this vectorization using comparison operator, let's suppose, as I have taken this example, what are the values which are greater than 5, let's say this time. So this will give you the Boolean value if the number is greater than 5. So 1 is not greater than 5, that is why false. 2 is not greater than 5, that is why it is false. Okay, 3 is not greater than 5, that is why it is false. Similarly, 4 is also not greater than 5, that is why it gives me false. 5 is equals to 5, guys. 5 is equals to 5, not greater than 5, that is why it is giving me false. But all the numbers from 6 is greater than 5, that is the reason it is giving me true. Okay, that is vectorization with arithmetic and your comparison operator. Now, if you want to actually see that what are these numbers for which the condition becomes true, that is what we call as masking. Okay, so what we do is we mask this condition a greater than 5 using indexing notation on our array A. That will give me all those values for which the condition was actually true, for which we have received true as an output in an array. Okay, that is 6, 7, 8, 9, 10. So this array, this A is my array. We have performed vectorization with arithmetic operator. Okay. And then we have performed vectorization with comparison operator. Then we have seen how masking works. Okay? How to get the actual value instead of trues and false. So it will return all the masking will return all the true value for the condition. Okay, all the true values for the condition. So this is how vectorization, selection, and masking works in NumPy. So practice it, revise the things. Okay, go through with this notebook. Thank you so much.